This is the brief on tensors, the physical object versus the mathematical components. So we're going to dive into the essential definition of a tensor, and we're making a really critical distinction here, the difference between a physical reality and the mathematical tools we use to describe it. It's absolutely the heart of understanding coordinate transformations. First, the whole concept of invariance is central. A tensor is the actual physical object. It exists all on its own, completely independent of whatever coordinate system you choose to describe it with. The physics doesn't just change because you switch your frame of reference. Second, building on that, you have to distinguish between the object and its components. The underlying physical object itself is invariant. It's constant. It doesn't change. However, the numerical components we use to describe it, they depend entirely on the basis you select. They're just the mathematical description, and they have to follow very specific transformation laws when you shift coordinates. And finally, let's look at the definition of the inverse metric tensor. We can define its components, which we write as GAB, using what's called the dual basis. Really, it's just the dot product of the dual basis vectors. And this is important because it verifies that these components transform exactly as a type 2-0 tensor should. Tensors prove that the physical reality remains constant. It's only our mathematical perspective that shifts.